Imagine a building hidden behind high walls in the middle of California's Tech Valley, but what comes out of it is changing the way billions live. Yes, we are talking about Apple's most secretive site, the Apple Silicon Fabrication and Design Campus. At first glance, it looks like just another office complex, but few know what magic happens behind its glass walls. This isn't just a place where chips are made, it's where Apple's vision of the future becomes real. Everything from the A-series processors in iPhones to the mighty M-series chips in MacBooks and iPads is designed here, and that too with such precision that a chip design is finalized every few months. But that's just scratching the surface. Thousands of engineers and specialized machines work here 24/7, calculating, simulating, and testing without stopping, without resting. And the most incredible thing, the entire design process is driven by AI algorithms that learn and improve with every cycle. Tim Cook calls it Apple's Brain Lab, and when you see satellite images, you realize why. From above, it looks like a sleek circuit board itself, as if the building is reflecting what it creates inside. Every corner tells the world Apple is not just a phone maker, but a force redefining computing. So let's step inside and see what is being built here that could change how the world uses technology in the years to come. But before we dive in, don't forget to subscribe to stay ahead on tech. When we buy a phone or laptop, we'll look at its display, camera, battery life, but rarely think about where the brain of that device is born. Inside Apple's Silicon Lab, it feels like stepping onto the set of a science fiction thriller. Instead of crowded workbenches, you see clusters of powerful servers and robotic testing arms tirelessly running simulations. First, let's talk about Apple's biggest strength, the design of its custom silicon. Unlike traditional chip foundries, Apple doesn't make chips the old way. Instead, it designs them in massive digital twins, fully virtual models where every transistor is tested billions of times. This process cuts years off development and allows Apple to create chips so efficient that even competitors are forced to rethink their approach. Now comes the role of AI and machine learning. These tools handle trillions of calculations, predicting heat output, power draw, and even how a chip will age over time. They learn from past chip launches, fixing mistakes before a prototype is built. This means fewer hardware failures and record setting efficiency. And the best part, humans here are no longer just designers, they are supervisors, guiding and refining what the AI produces. But the future Apple envisions goes beyond phones and laptops. The lab runs 24/7, no weekend, no holidays. The design servers never sleep, and if a cluster fails, backup systems take over automatically. Data on chip yields, thermal tests, and user experience flows continuously through Apple's global network, meaning a bug spotted on the other side of the world can feed directly into the next day's design iteration. This self-healing design pipeline is why Apple can launch multiple chips every year, all while pushing performance further. Another surprise is Apple's automated validation rigs, small robotic systems that test chips under extreme conditions from -40 degrees to over 100 degrees Celsius. No human intervention needed. These robots run day and night, ensuring every chip can survive real-world stress. The entire process is so streamlined that from concept to final silicon can take months, not years. To be honest, Apple's Silicon Lab has become a place where hardware meets deep learning at a level unseen elsewhere. It's where Tim Cook's dream becomes real, that design should be as important as function. But what really shocks industry insiders is Apple's upcoming secret projects. First is the M4 Ultra, rumored to be so powerful it could replace workstation chips used by movie studios and scientists. Then the much-awaited Vision chip, designed to power Apple Vision Pro headsets, reducing weight, heat, and extending battery life. This is expected to redefine augmented reality, making it mainstream. But the real game-changer, Apple's long-rumored Project Titan, an electric car said to run on a next-generation automotive chip from this very lab. Smaller, cooler, and smarter than anything in the market, it could make autonomous driving a reality at scale. And at its heart will be the 3nm Apple Silicon. Not just a processor, but an entire self-driving brain built into a single chip. Even more stunning, Apple is working on AI cores so advanced that devices could handle complex tasks offline without sending data to the cloud. This would mean faster responses and better privacy. And if rumors are true, the next Apple Watch will also get its own custom neural engine, increasing health tracking accuracy to medical levels. All of this is possible because of the design campus hidden behind that minimalist facade, where rooms of servers and AI clusters quietly craft the next leap in consumer tech. The next time you hold an iPhone, MacBook, or watch, remember, it isn't just a gadget, it's the product of thousands of simulations, millions of lines of code, and the vision of making tech disappear into our lives effortlessly. Apple isn't just making chips, it is laying the blueprint for the intelligent devices of tomorrow. So when you pass by that anonymous glass building in California, remember, inside it, the future is being built. one transistor at a time. Imagine a place hidden among the hills of California, not as famous as Silicon Valley, but what comes out of here is quietly transforming the entire digital universe. Yes, we're talking about NVIDIA's most secretive and powerful facility, the AI Research and Supercomputing Lab. At first glance, it may look like an ordinary office park, but what's happening inside is nothing short of revolutionary. This is not just a lab, it's the birthplace of the future of artificial intelligence, from the GPUs that power your favorite games to the most advanced AI models that can write, paint, and even talk. All of it begins here, and that too so fast that new architectures and software updates are released every few months. But this is just the beginning. Thousands of high-performance GPUs run 24/7 training large language models, analyzing terabytes of data without resting. And the most astonishing part is that these systems learn from each other and get better over time. Jensen Huang, NVIDIA's founder, calls it the engine room of the AI revolution, and when you look at its satellite images, you understand why it looks less like a building and more like a digital fortress. Every corner of this place silently announces that NVIDIA is no longer just a chip company, but has become the brain factory of the AI age. So let's step inside and see what's being built here that could change our entire digital life. Before going further, don't forget to subscribe so you don't miss the next tech story. When we use AI apps on our phone or cloud gaming services, we rarely think where the power actually comes from. Inside NVIDIA's lab, it feels like stepping into a science fiction film. Instead of rows of humans, you see massive racks of DGX servers, each with dozens of AI-optimized GPUs, the heart of everything. First, let's talk about NVIDIA's biggest strength, its CUDA architecture. This is not just code, it's the foundation that makes AI training 100 times faster than on ordinary chips. Earlier researchers took years to train big AI models. Now, with NVIDIA's clusters, it can be done in weeks or days. Now comes the role of AI itself. The AI tools here optimize their own training processes, detect data bias, and even suggest better algorithms, meaning the models not only get built faster but smarter too. And humans here become mentors rather than mere programmers. But the real magic is the scale. This lab never sleeps, no weekend, no downtime. Sensors watch over temperature, power, load, and performance. If a cluster fails, the backup automatically takes over. It's a self-healing supercomputer lab, ensuring that experiments never stop. Another surprising thing inside are robotic cooling systems and automated cable robots that check connections and adjust servers if needed. These small things save time and reduce human error so much so that AI development cycles shrink from months to days. To be honest, this lab has become the place where science meets code in a way that was unimaginable a decade ago. NVIDIA's mission isn't only to make chips, but to build an AI ecosystem that every developer from gaming to healthcare can use. And what's coming next is even more shocking. First is the new Hopper series GPUs, rumored to power AI models so large they can simulate human-level language fluency. Then comes Grace, NVIDIA's first ARM-based CPU for data centers, which could transform energy efficiency and speed. But the real game changer is Project EOS, a next-generation AI supercomputer built entirely with NVIDIA's own hardware and software, designed to train trillion-parameter models, which could lead to AI that understands context as well as humans. Even more incredible, NVIDIA is building AI systems to design better chips, meaning the next GPU generation could literally be co-created by AI. This feedback loop could make each new chip smarter than the last. And that's not science fiction, it's happening inside this lab right now. The entire world's tech giants, from Microsoft to Google and OpenAI, rely on NVIDIA's GPUs, and every improvement here means breakthroughs everywhere else. But what really sets this lab apart is its vision. It's not just building for gamers or researchers, but laying the groundwork for AI robots, autonomous cars, smart factories, and digital twins that mirror the real world in code. In the future, when your car drives itself or your home assistant understands complex questions, remember it started with these servers humming day and night at NVIDIA's secret lab. Even more interesting is how these systems learn to share heat, power, and data so efficiently that a single supercomputer here can outperform thousands of older servers. This means lower cost, greener AI, and faster breakthroughs. Looking at this lab, one thing becomes clear: NVIDIA is no longer just competing in the market, it's setting the pace for the entire AI race, and the rest of the world is now trying to catch up. In the future, people won't just say that's a fast GPU. They'll say this is AI made by NVIDIA, and know it. came from this digital powerhouse. Every second data flows in, new models are trained, and the boundaries of what AI can do are pushed further. When we talk about a lab this size, we usually imagine huge energy consumption and waste, but NVIDIA has reimagined that too. The data center uses liquid cooling and AI-managed power to cut energy use by almost half. The entire lab is powered by renewable energy, and heat generated by the GPUs is reused to warm nearby offices, making it a model for green computing. NVIDIA's vision is AI that doesn't cost the earth, and this lab is proof it's possible. Now let's talk about the biggest challenge. Building a lab of this scale needed new kinds of power grids, cooling systems, and even specialized floors to handle the weight of thousands of GPUs. Construction faced delays during COVID, supply chain disruptions, but work never fully stopped. Engineers redesigned layouts via VR meetings and AI-optimized hardware shipments so the lab could come online faster. This is why NVIDIA's AI lab isn't just a building, it's a statement to the tech world that where there is innovation, even global crises can't stop progress. But the most futuristic thing happening here might surprise you: the creation of AI agents that can themselves write code, debug software, and even co-design new hardware. NVIDIA calls this AI for AI, meaning a loop where machines make better machines. So the next time someone asks what NVIDIA does, don't just say they make graphics cards, say they make the future. If you like this video, give it a like, subscribe, and comment what AI topic you want next. See you in the next episode. Until then, stay curious and connected to tomorrow.